for your friends to join. Okay, I hope that, okay, Assalamualaikum and good morning. We have almost 14 students with us today. I was told that this class for the Indonesian students from ITS, they also have this toxicological industry class, right? This morning at 9. Dirham, are you taking the toxicological industry? Do you take that class? Okay, can you all hear me now? I was told that the ITS batch, they also have toxicological industry class, right? At this hour?
Tak tahu.
Huh?
Tak tahu, Doktor.
Oh, I forgot you Dirham. Okay, sorry. Yeah, okay, it's okay. Okay, let's say actually I've already asked them to try to rearrange with their class lecturer, if possible, to to have this time for this class. But if it is not possible, is it okay for you if on Monday we have class until 3? Are you all free? Malaysian and Korean students, are you all free?
Sorry, Doctor.
On Monday. Do you have something on Monday from because our class starts at 12, but if I make it into 12 to 3, is it possible for all of you?
I think 12 to 3.
Yeah, 12 to 3 because they have a class today, the ITS students.
Oh. I think it's okay if we don't have a FYP class. But macam semalam kita ada FYP class at 3.
Oh, you have FYP class at 3.
But
usually it's online, right? FYP.
Online.
FYP is just lecture, right? And it's not weekly. Is it weekly class?
No, I'm not sure.
Oh, okay. So, yeah, if possible, I want to have this time also for your class. But if it is not possible for them, I can have the class. Of course, we will have maybe 10 minutes break for your Monday class, so that you only have one class for 3 hours. Is it possible?
I think it's possible.
Okay. I will try. That is my plan B. Plan B for this class. Okay. So they will only listen to the recording that I have today. But the Korean students, they are not here. Maybe it's too early in the morning. But it's okay. We can start our class, and I will share the slide in the UKM folio. So I hope that all students who cannot attend this class, they can always have the recording and also the slide in the UKM folio. Okay, so I share and we continue because it's only 1 hour today. I want to finish the syllabus for this week. Okay. Okay, can you all see my slide?
Yes, Prof.
Okay, so we continue on. Actually, I've already uploaded the file in your UKM folio this morning. Okay, so we follow through. Okay, actually we stop here somewhere here. Okay, so actually we are yesterday we were talking about 2 types of filter, sand filter, which is actually it's a physical process, but the mechanism on which the colloids or suspended solids is removed actually depends on a few mechanism. Adsorption, straining, biological also, because we have that slime layer of biofilm, and we also have what else? These 4 methods. These 4 methods. About this, okay, biological sedimentation, sedimentation, and also electrolytic action. So of course the decision on whether to use slow sand filter or rapid sand filter generally depends on the amount of flow that you want to treat, because usually after sedimentation, the quality, the suspended solids, the turbidity, they still have 1 to 10 NTU, so or 5 NTU. So that's why we need this filtration before the water is treated for disinfection. Okay, so we continue on from yesterday. Okay, so the rapid sand filter, because this is something that you can filter very high loading, very high loading. So you need to backwash the system, meaning that why you need to backwash the system, because once you arrive at the head loss, head loss meaning that the effluent turbidity will increase. So that's why you need to backwash the system, meaning that you have accumulated all the solids in the pore of the grain or media that you use for your filtration. That's why you have to backwash the system to dislodge or to make sure that you wash out all the accumulated solids in the pores of the media. Okay, so this is the equation because even though it's due to the suspended solids, but even at the clean filter beds, clean filter bed, meaning that at the beginning, before you input any influent to your filtration unit, you have already experienced a head loss. So the head loss actually due to the piping, due to the gravel in the system, due to the media, clean media in the system. So the equation that is used to calculate the head loss in clean bed is common Cozzani equation. So it's very easy because it's given here. So you have to calculate the head loss in terms of in meter. You have this value. You have to calculate the V over A, the grain volume over the grain surface area. You have this. And then you also calculate the filtration rate here, the filtration rate here. So you calculate these two values based on the data that you have for your system. And then you calculate the head loss. Okay, so this is the head loss for clean filter beds. Okay, the head loss during filtration, meaning that after you use your filter to clean the amount of water that you want, you will again experience the head loss due to the suspended materials in the pore of the media. So this is the equation. Actually, this equation is based on the derivation from the common Cozzani equation and also the Bernoulli equation. So this is what you get. So it is simplified here. So you can get the head loss during filtration or non-clean water. You get this equation. I will show you how a sample of calculation at the end of the lecture today. Okay, this is the head loss during filtration or non-clean water. So head loss due to the accumulated suspended solids is head loss during filtration minus the head loss the head loss during the clean filter beds. Okay, so this is the equation, and then okay, and then the filter cleaning or backwashing. Okay, so the head loss through the filter exceed the design value because you have already calculated the head loss where you have to backwash the system, or pre-selected maximum filter running time has passed since it was last clean. Sometimes after you run the filter unit for sometimes you can estimate what is the operation cycle for this filter, meaning that maybe after 20 hours you need to backwash the system. Okay, so backwash is basically cleaning the system. Okay, so to ensure proper operation of the filter, the design engineer must consider the settling velocity of the media, the backwash flow rate. So how do you want to backwash the flow rate that you want to backwash? Because you have this flow meter and you have to provide water to backwash the system. You need to know the backwash flow rate, head loss during backwash, the duration of the backwash cycle, whether you are using 5 minutes or 10 minutes, the quantity of water required to backwash each filter. These are all things that you need to specify when you design a sand filtration unit. Okay, the purpose of backwash the filter is to remove deposited flog without washing out the media, meaning that you just remove the suspended materials accumulated in the pores of the media. Therefore, the vertical velocity of the water during the backwash must be greater than the settling velocity of the flog, but less than the settling velocity of the media. Okay, then when you want to determine the velocity of backwash rate, you can calculate based on this formula. Or you can also use this formula to calculate the backwash flow rate. So you will be able to get the flow rate for the design backwash flow rate based on here, 1.3, meaning that you provide some safety factors to this flow rate. So this is the equation. Okay, but sometimes it's a bit difficult for you to calculate. When you buy the media from manufacturers, they will be able to tell you how to backwash the media depending on the types of media that you are using. So maybe like Nelson Water, this is a famous provider for this media. They have already provided you with values, the tables, so that let's say you use sand as your media, and your tank diameter is like maybe 16 inches. So the backwash rate that you need to use is 45.4 gallon per minute. So you can always use the formula here, this formula or this formula, or you can also refer to the table from the manufacturer to determine the backwash flow rate. Okay, so sometimes this is only the beginning of your operation of the backwash cycle. After you run the reactor for the filtration unit for quite some time, you'll be able to tell what is the cycle for you to backwash the system. Okay. Typically, now we are talking about the support system, because yesterday I showed you this, the filtration units. So this is talking about the backwash of the media, and this one is about the support system of the, they are not media, but they are the support system, the under drain and also the gravel. So the gravel layer and the under drain system. Actually, the filtration is based on the media, whether the sand, anthracite or garnet. But all of this system, you have this gravel layer that is located immediately below the filter media. So the purpose is to separate the filter media from the under drain system and to prevent media particles from clogging the under drain or orifices. So to dissipate the backwash water jets from the orifice. Gravel layers are typically 400 to 600 millimeter of depth. Okay, so actually there's no function of the actual purification of water. In terms of purification of water, this gravel layer is not filtering. Actually is for slow sand filter simply to support the sand bed, but for rapid sand filter serve to distribute the wash water evenly throughout the sand and serve to distribute the filter water evenly throughout the perforations to under drainage. Usually placed in 5 or 6 layers, finest layer on top and hard, rounded and durable. So the gravel should be hard, rounded and durable. Okay. So this is, and then you have the gravel layer, and then you have the under drain system. So the under drain system is actually to provide structural for the entire filter system. So it must have the structural strength to support the weight of the gravel and the media layers on top and to resist hydraulic pressures of backwash water flow. So this we have this pipe lateral under drains as the under drain system. Okay. I think this is the the backwash water. How much quantity of backwash water that you need? Quantity of filtered water every 24 hours operation is based. The filtered water is you need to multiply by the time of operation. So you will get the quantity of water that you filter through the sand filter unit. The filter area is the quantity of the filter divided by the velocity of the volume of the filter unit. So quantity of wash water is the surface area of your filter multiplied by the volume of backwash water. So the rate of washing, not the volume, rate of washing. So the quantity of backwash water is the flow of wash water times the time that you backwash the system, maybe 10 minutes or 5 minutes. So percentage of filter water for backwash water is the amount of backwash water divided by the amount of filtered water. So how much, what is the percent of backwash water that you need for your this amount of filtered water? Okay, so the advantage, you can see that this is about the rapid sand filter system. So you can see the advantages of rapid sand filter. The bed water may be treated. Land required is less compared to slow sand filter. Operation is continuous. And also disadvantage, required skilled maintenance personnel for operation, less effective in bacteria removal because it is fast, it is being backwashed. So because last time the slow rate to the slow sand filter make this biofilm grow on the media, on the media surface. But this one, because it's very the velocity is high of the backwash, so you get less bacteria that can get attached to the media. So operational troubles. But these are the items that you need to specify when you design your slow sand filter or rapid sand filter. So you can see here the filtration rate for slow sand filter is only 2.4 to 3.6. And rapid sand filter 100 to 150. So there is a big jump here from slow sand filter to rapid sand filter. Okay, so you backwash the system, but here you have to replace the upper layer of sand. You have to collect the upper layer of sand. Operation and maintenance costs low for slow sand filter, but high for rapid sand filter, and because we have this backwash. Efficiency of disinfection 99%, but this one only 60%, but they can treat a very high amount of water. So loss of head, the one that you calculate, meaning that you need after the maximum 0.9 meter, you can allow the loss of head after the operation minus the loss of head for the clean filter is 0.9 meter. But for rapid sand filter, it can go up to 3 meter. So for slow sand filter, remember, if you design your system using slow sand filter, then you do not need to provide the coagulation system. Maybe flocculation but no coagulation. But for rapid sand filter, it is required. The coagulation part required for satisfactory filtration. Period of cleaning once every 2 to 3 months, 24 to 48 hours. Then you have to backwash. Amount of wash water, you just use the wash water for washing the sand that you collect on the top of the system. But here usually 2 to 4% of the filtered water based on just now the formula here. Okay, the formula here. Okay. Filter bed area 5 to 200 meters square meter per filter, minimum of 2 filter. But for a rapid sand filter, 100 square meter in 2 parts of each 50 square meter, meaning that for rapid sand filter, usually you need to design your filter width, the area of the top filter is only 50 square meter, but this one can go to 200 square meter. Operation less flexibility due to seasonal variations in raw water quality. So it is not flexible because there's no backwashing. But if you use rapid sand filter, let's say you have higher turbidity raw water quality, then you can increase or you can shorten the cycle period for backwashing, so that you can wash out all the accumulated solids in the pores of the filter more regularly for rapid sand filter. Okay, so this one actually these are slow sand filter and rapid sand filter are also gravity filter, gravity type. So we specify this rapid sand filter and slow sand filter based on the filtration rate. But we can also classify filtration unit based on driving force. So filter can be classified as gravity type or pressurized type. The gravity type or pressurized type. So the major differences between them are the head required to force the water through the media bed and the type of vessel used to contain the filter unit. So gravity filter is an open, usually require 2 to 3 meters of head and are housed in open concrete or steel tank. These are the rapid sand filter. Gravity filter are used on both large and small system. Filtration rate of the rapid gravity filter is 120 to 180 volumetric meter per square meter per day. Okay, so actually the slow sand filter and also rapid sand filter are gravity type. But gravity type can also have rapid gravity filter, meaning that if you have higher flow rate, you cannot accommodate with this filtration rate, then you can also use gravity type filter, but you use rapid gravity filter here. Okay, so this is the filtration rate, the filtration rate for rapid gravity filter. Or if you have a very high rate compared to what you can accommodate with this rapid gravity filter, you can use pressurized type. So this is the pressurized type filter, usually require a higher head, 10 to 15 meter, and are contained in enclosed steel pressure vessels. Of course, it is more expensive, but you can save lots of area, and also you can filter higher amount of water. Because of the cost constructing large pressure vessel, pressure filter typically are used only on small water plants. So the filtration rate can be 240 cubic meter per cubic square per meter squared per day. So you can compare. This one 240, the rapid gravity filter 120 to 180. And you can also compare that for rapid sand filter 100 and 150, and slow sand filter is 2.5 to 3.6. So this is for you to choose. I think most of you who choose to use river water for your water treatment plant design, then you need to use this sand filter. So sand filter, so how you want to determine which type of filter you want to use? It's basically first about the filtration rate, meaning that because you have determined the based on the community that for the treatment plant that need to serve for the community, then you will have to determine how much water to be treated. So per day. So you need to determine what is the filtration rate allowed for your system. So you can use from SSF, RSF. You can use also rapid gravity filters, or you can choose pressure filters. So this is for you to determine which type of filter that you want to use. So water is allowed to pass under a pressure greater than atmospheric pressure through a closed cylinder. Similar operation with RSF, except that the coagulated water is directly applied to the filter without mixing and flocculation. So meaning that if you have a very small space and you don't have space to have this coagulation unit and also flocculation unit, you can use this pressurized filter. Okay, you can also classify filter based on the direction of flow. You can have most likely that all of the sand filter are downflow, where the flow through the media bed is downward. Or you can have these upflow filters where the water flows upward through the media bed, as is illustrated. So this type of system is rarely used in granular filters, but is sometimes used in granular activated carbon. So it's very difficult if you just use sand that you have these upflow filters. So you some experiments say that upflow filter is more efficient, meaning that the efficiency is better. But of course, for granular filter, it's difficult because usually by gravity, it's easier if you have this sand filter. But if you are using the media as activated carbon, you can use upward filter, because you have higher pore surface between in the activated carbon compared to the granular filters. Okay. So selection of filter media is important also in filter design, as the media control solid holding capacity of the filter bed, hydraulic loading rate of the filters, and finished water quality. So you have single or mono media, dual media, or you can use mixed or multimedia. So media design parameter commonly are specified by effective size and uniformity coefficient. So effective size is the size of the standard sieve opening that will pass 10% by weight of the media. I think I think all of you have already very familiar with this effective size and uniformity coefficient in your structure lab. I guess because I'm not civil engineer, but I guess you are familiar with this. The uniformity coefficient is the ratio of the standard sieve opening that will pass 60% by weight of the media to its effective size. Okay, and also the media need to be resistant to acid attack, and also need to be hard. Okay. So when you use single medium filters, usually is using the well-graded sand. So large particle size are at the top, followed by smaller size particles. But the problem is when after you you have the flow. Let's say if you use rapid sand filter and you use single medium filter, at the beginning you put the larger size what we call this reverse gradation, stratification, meaning because of course the larger media will be at the bottom, the smaller media will be on the top. So the grains, the grains of the sand. But this will always make the system inefficient, because when you have the very small grain on the top, only 4 to 5 centimeter of the filter bed is utilized, because you have already the straining, the straining happens, and it will stop, it will stop more influent from going in depth into the media. So this is it's not good single media filters because of the reverse gradation. So they become ineffective because of this reverse gradation. Okay, so the problem can be minimized by specifying a larger diameter media with a uniformity coefficient close to unity, and by using a deep medium bed. So that is difficult for the larger media to be settled deep down the bed. Okay, and you can also have dual media filter. So this is the solution to the problem of reverse gradation. So you can have anthracite coal and sand filter media. Of course, you put the anthracite on the top because it's lighter than the sand, and it has a specific gravity of 2.65. Therefore, a larger anthracite grain has the same settling velocity and is much smaller sand grain. So the anthracite grain will be always on the top, so you can increase the effectiveness of the bed for filtering the influent coming in, because the anthracite, they have larger pore size, so you get more the usage of this depth of filter is higher. Otherwise you only use the top of the filter, the media filter. Okay, you can also have mixed media filter. Typically 3 materials are used: anthracite, sand, and also the garnet. So you always have this anthracite on the top, and then you have sand, and then you have the garnet media. So filter efficiency is a function of certain physical characteristic of the filter bed that include the porosity of the media and the ratio of the media depth to media grain diameter. So there are 2 ways to determine the depth and size of filter media. First is pilot testing, and also experience from past study. Of course, pilot testing will increase the capital expenditure of your water treatment plant. But if you have experience gathered from past study, then you can always determine to select the filter media depth and size. Okay. So these are the typical media design values for various filters. So single medium filter, dual media filter, and mixed media filter here. So I think you can always single medium filter, maybe can be the media can be from sand media or anthracite layer. Okay, so you choose one. But dual media, you can have these 2. Okay, mixed media, you can have these 3. Okay. So how to design the calculation for rapid sand filter. You have to calculate the flow through one filter. But if like for rapid sand filter, usually one filter you specify the surface area to be like 50 square meter. But if a slow sand filter, it can go up to 200 square meter. Calculate the surface area of one filter, calculate the length of the tank, calculate the volume of backwash tank, calculate the openings of the manifolds and laterals of the under drain system. Usually this one, you will get advice from the contractor. Okay, so I want to show you examples for designing and calculation involved in the filtration system. So maybe I will give you homework, only 2 questions next week, but this week I'm going to give you examples. First, you need to determine the effective size and the uniformity coefficient for the sand media characterized by the sieve analysis results presented in the following table. Let's say you have to determine the effective size, and also the uniformity coefficient of the sand media that you have. So these are the sieve number, and this is the opening of the size opening of the sieve, and this is the percent of weight passing. So you have a different sieve number here, and also based on the size opening. So what you have to draw in your graph is the sieve size based on the opening versus the percent weight passing. So you will get this. You will get this graph. So from the graph, we estimate the D10, meaning that the effective size is D10. Weight of passing 10%. So the effective size is around 0.51 millimeter. And to determine the uniformity coefficient is when you have the percent weight passing at 60%. So from the 60%, you can see here the uniformity coefficient is around appear to be 0.73 millimeter. So uniformity coefficient is the effective size divided by the the size at 60% divided by the effective size at 10% weight passing. So this is the uniformity coefficient of your media. So this is example how you determine the effective size and uniformity coefficient. Okay. Another important calculation is about the how you design the media filters. Okay, let's say you have to design a granular media filter for a water treatment plant with a design flow of 24 million gallon per day. This is the flow rate, the Q to the filtration unit. So for a filtration hydraulic loading of 4 gallon per minute per square meter, determine the total filter area required for filtration in square feet. So the filtration hydraulic loading, usually you get from the table of the design capacity. You can determine which one you want to use. Then you select, then you divide the Q with the hydraulic loading. So you will get the A, which is the total area needed. The total area needed for your filter. And then you divide the here it is specified that each filter is square with area between 450 and 650 square feet. Okay, so if you are not given this area, you can always assume that if you are using rapid sand filter, you can go to 50 square meter. But if you use a slow sand filter, you can go up to 200 square meter. So, but here it is given. They want the filtration unit to be in this area from 450 to 650 square feet. So you can calculate how many filters are needed. So this one 7, this one 10. So you select 8. So each will be 4164 or 520 square feet in area. So you can say here usually because you want it to be square, meaning the length and width are the same, so you can get the dimension of your filtration unit. So you get this. If you use 7, the length will be 25, width also 25, 8, 23 to 23. If you use 9 filter, you can use this length and width, okay? Because of course, for designing, it is not very definite, the number of needs. So you have to use justification on how many filters you want to use based on the design flow that you have for your community. Okay, so you can also be asked to determine the superficial filtration velocity and the pore velocities in both the anthracite and sand layers. So you need to determine the filtration velocity, because let's say you want to determine the backwash water, then the amount of backwash water that you need, then you need to determine the superficial filtration velocity. As I mentioned, you can use equation to determine filtration velocity. You can also use what is this? The tables from the manufacturers. Okay. I hope that when you go back, you look at this calculation carefully, and then you can ask me question if you don't understand any of this calculation, and you can ask me during our next lesson, next week. Okay, calculate the detention time through the entire depth of the filter. For anthracite media, how do you determine how long each cycle of this of the filtration, the detention time? For the anthracite media, 1.25 minutes. For the sand media, it will take 1.9 minutes, depending on your bed depth and the pore velocity of your media. So if sometimes you want to also determine how long will it take for the filtration unit to occur. Okay. So this is a question about detention time. This one about head loss in clean filter. So as I mentioned to you, I show you the Cozzani equation just now. So this is the calculation if you use anthracite layer. If you use sand layer, then you calculate the head loss in the sand layer by summing the head loss in the anthracite layer and also the sand layer. Okay, so this is the head loss, the total head loss for the clean filter for a dual media filter. So I hope that you can compare this value with the equation that I show you in this slide as well. And then you try to calculate on your own and put all the units inside, because sometimes students, they make mistake not on the formula but on the conversion unit. The conversion unit, when they put input all the values into the formula. So you can take the formula that the Cozzani equation, and you start calculating, and you must get this value, because I don't really like that if you calculate this only with the values without putting all the units. So I think for your okay, I think for your homework, I'm not going to give you any more question, but I want you to use graph paper, and then this one I want you to calculate back using your own handwriting, and you input all the units when you do the calculation. By doing this, you'll be able to, I don't have to correct your assignment one by one, but I will be able to tell that you have understood, not only to copy, but I want you to do the calculation and input all the units, because I want you to really understand how to get the answer here. Okay, so this is your homework. Your homework is to redo this using your own handwriting, and I want you to use graph paper for this. Okay. Okay, head loss in non-clear filter. Also, you use the equation that I've given you, and you input the value, because the A and B is the media, the media after the operation has started for some time. So it's already blocked. It's the porosity is already blocked by the suspended solids or colloids that you filter. So the size will not be exactly when you have the clean filter media. So how do you do the get the size is by estimating the values of A and B using the values that are given here. So you get the value of A and B, and then you can calculate the head loss for the new flow rate. Okay. So I want you to do this as well, because this the units are not given here. Okay, so actually this one I've shown you the Nelson water values. Sometimes it's very easy for you to determine how to backwash depending of the media types that you purchase. You acquire for your filtration unit. You can always ask the table that have been provided by the manufacturers, because they have run the operation based on experience. So they have all the values to input in the table. Okay, so basically this is it. It's about the filtration unit. Filtration unit, this is only one filtration unit. That's why the clear water is you distribute to town. But for your water treatment plant, this is only one of the units in the treatment terrain. So you have to this one after usually after the filtration unit, you will go to the disinfection unit. So you have this wash water storage for your backwashing. This is the under drain. This is the gravel, sand. This is only monomedia filter. So water level when filtering. Of course, when you filtering, water level when washing. Water level when washing from settling tank, you always have all the valve here. So when you backwash the system, you close all the valve, okay, and then after you open the valve, after you have completed your backwashing, you open the valve for the wash drain. Then you start the operation again by making sure that this valve already closed, the wash drain and also the backwash water. Okay. Okay, I think that's all for filtration unit. Okay, so it is very important for you to understand which type of filter to be used and what are the design parameters that you need to tell when you design your water treatment plant. Okay. Any questions from all of you? We have 3 more minutes. Any questions, students? Any questions?
Prof.
There?
Tadi
Okay.
Prof sudah buat dari page 19 sampai 25 Kena redo ke?
Kenapa?
Kena redo assignment tu. Lepas tu input.
Yes, semua. Because previously I thought of giving you new problems, but I think because this one they don't put the unit, so I want to make sure that you are able, because when you do using your handwriting, you will be able to understand, understand the step, and I don't have to mark your assignment because I know the answer is there, but I want you to do it again. All of this. Okay. Okay, I want to ask you one question. Okay, actually, I just know that the Indonesian and the Korean students, they are sophomore, and the Indonesian second year. For the design project, do you think that is something that need to be changed, the group, or for you it's okay? Because I don't want to affect your grade, What do you think? If you are okay, I mean because I thought that it's good for you to understand each other. We need to make use of this better mobility program to know more about students from other countries. But of course, maybe it's a bit difficult for you to discuss because you have different class, different time with them.
Yes, Prof. It's quite difficult actually.
Oh, it's quite difficult. So maybe I will rearrange back your group.
Because most of us are at the campus, so if we can meet each other, it is much easier for us to settle down the design assignment.
Oh, really? Okay. Okay, good. Because I just think about it because I think maybe it's difficult for you because it's for you, you want the good grade, of course, the good grade, and for them, maybe it's experience, experience of. Okay, I will rearrange and I will let you know next Monday, on the new group. Okay, so I hope that you still have time because the first presentation is not that difficult. It's just you can start, all of you can start searching for water quality characteristics, and when if possible, I will let you know the new groups, and if and then you can also make sure that you have your literature, and then if I give you group 2 members, then if you have 2 rivers that you want to use, you can select. You can discuss which one to select. You can discuss which one to select. Okay, so I will rearrange the group. Okay, see you again next week.
Prof. Thank you so much, Prof.
Okay.
Selamat berpuasa.
Yes, selamat puasa.
Thank you.